In this video, we'll be covering notation, standard forms, and rules of differentiating. The derivative of a function is represented by f prime of x and dy dx. This is called Leibniz notations. These two notations are called Leibniz notation. Now, in calculus, dx, and there'll be something here. There'll be some expression here. Is the shorthand representation for the derivative, differential operator, which signifies that we need to simplify the expression first and then apply the derivatives, apply the rules of differentiation to find the derivative. So make sure you understand these two notations and standard forms of the derivative. There are two basic rules that we need to cover for everyone who are learning calculus for the beginners. There is a power rule and a constant rule. Those two rules are two fundamental rules in calculus that are used to differentiate in calculus. Number one, the rule that I'm going to cover up is called power rule. The rule is used to differentiate functions in a form of, let's say maybe it's f of x is equal to a x to the power of n, where a is the coefficient of x and n is the exponent of x. So to apply the power rule, you simply multiply the coefficient of x by n and then subtracts by 1 from the exponent. So this is what you're gonna get from. So you take this exponent n and multiply by the coefficient of x, and from this exponent you're gonna subtract by 1. This is the power rule. This rule is used to differentiate in power rule. Let us make an example. For example, let's say maybe you have the function f of x is equal to x squared. Now you're gonna take 2 and multiply by the coefficient of x, which is 1. So it's gonna be, our derivative is gonna be 2x, then it's gonna be 2 minus 1. 2 minus 1, it's simply 1. This is our derivative. This is how you find derivative, by using the power rule. The second rule that we need to cover is called constant rule. It's our second rule, constant rule. So this rule is used when differentiating a constant function such as f of x is equal to c, where c is the constant. The derivative of a constant is always 0. So if you're gonna differentiate this function, you're gonna get 0. F prime of x is going to be 0. So for example, let me make an example. Let's say maybe we have f of x is equal to 5. The derivative of this function, it's going to be 0. So the derivative, make sure you commit this in on memory, because you can apply this rule a lot, not only in this video parts, maybe on your exam, on your coming exam on calculus. So make sure you understand these two basic rules, power rule and a constant rule. So the derivative of a constant rule is always 0. These rules are essential in calculus and are used to find the rate of change of a function with respect of its variable. By understanding and applying these rules, you can differentiate a wide range of functions with easy access. So stay tuned to this video. I'll be providing you with a plenty of exercises and some great conceptual examples in this video. Stay tuned to this video. In this question, they are saying determine f prime of x. So on number 1, we are given f of x is equal to x squared minus 3x to the power of 4 plus 8x to the power of 3 plus 3x plus 1. So to determine the derivative of this function, it's gonna be f prime of x is equal to, so it's going to, you always say it's gonna be 2 times 2. So 2 times 2, we're gonna get 4x. So 2 minus 1, we're gonna get 1. Then 4 times 3 is 12. X to the power of 4 minus 3 is 3. Plus 3 times 8 is 24. X to the power of 2. And the exponent of 3x is just 1. So it's gonna be 1 times 3. So it's gonna be 3. 1 minus 1, you're gonna get 0. And anything to the power of 0 is simply 1. And 1 times 3, we're gonna get 3. The derivative of the constant, 1 is the constant in this expression. So the derivative of 1, we're gonna get 0. And anything, if you add anything to 0, you're gonna get the same thing. So this is our derivative. That's how you get the derivative. So let us try another questions. Now on number 2, determine dx 8 x to the power of 4 minus 6 square root of x plus 5 all over x. So what I like to do when I get questions like this, I like to make everything where if I'm given the square roots, so I'm going to change the square roots into an exponential form. And when I'm given a fraction, I'm going to change the fraction into an exponential, especially if the variable that I need to differentiate is on a denominator. So I'm going to take that variable into a numerator. So let me show you in details. So you're always gonna keep this dx. So it's gonna be 8x to the power of 4 minus 6 times x to the power of 1 over 2. When changing this radical into an exponential form, it's gonna be x to the power of 1 over 2 plus 5x to the power of negative 1. When you take the variable when you take the denominator into a numerator, it's always gonna be in the power of negative 1. So let us differentiate, because everything is in an exponential form. So it's going to be 4 times 8. So 4 times 8 is 32. X to the power of 4 minus 1, you're gonna get 3 minus 6 times half. 6 times half is simply negative 3. X to the power of half minus 1, we're simply gonna get negative half. And then negative 1 times 5, you're gonna get negative 5. X to the power of negative 2. This is our final answer. That's how you differentiate. And after you've applied the process of the derivative rules, there's no need to carry on with this dx. So there's no such thing like dx is equal to maybe all this stuff. So you're not gonna get the correct answer. This is the correct answer. So make sure you understand how we arrived to this answer. So feel free to post a comment on a comment section, so that I could be able to help you further, so that I could create more content on these stuffs. Now feel free to pause a video and try this one. Part A is just g of x is equal to 4. Feel free to pause the video and try this one. Now to differentiate g of x is equal to 4, it's simply going to be 0. The derivative of a constant is simply 0. Now let us try this one. Try this one. Feel free to pause the video and try part B. Part B is g of x is equal to 1 all over x. Feel free to pause the video and try this one. So in this one, we are going to take our variable x, the one that we need to differentiate, to the numerator. So it's gonna be x to the power of -1. Always when you take the denominator to the numerator, you're gonna multiply the exponent by -1. So it's going to be -1. When differentiating this, you're going to get -1 times 1. You're gonna get negative x to the power of -1 minus 1. 1 minus 1, you're gonna get -2. So try this one. It's part C. It's simply g of x is equal to x cubed. So my drawing tablet is jamming. So it's x cubed plus 2x squared plus 3x. Let me simply erase everything here and maybe just give a break in my drawing tablet, because now it's starting to jam. I don't know why. So but I'll be investing for a new one maybe in future. It is what it is. So g of x on part C, it's simply g of x is equal to x cubed plus 2x squared plus 2x squared plus x plus 4. So let me put 2 here, 2x squared. So differentiate this one. Feel free to pause the video and try to differentiate this one. So everything is in an exponential form and we do not have any fractions in this expression. So to differentiate this one, we simply gonna say 3 times 1, the coefficient of x cubed. So it's gonna be 3 x to the power of 2. 3 minus 1 is simply 2 plus 2 times 2 is simply 4 x to the power of 1. Differentiating the exponent here, it's 1. 1 times 1 is simply 1, and 1 minus 1 is 0, and anything to the power of 0 is simply 1, and 1 times 1 is gonna be 1. The derivative of 4 is simply 0. So we're gonna leave our expression as this, our derivative. So let us try another one. It's part D. So on part D, it's y is equal to x squared minus square root of x all squared. Now to differentiate this one, we need to first simplify the expression. So the best way to simplify this expression is to expand. And our second step is to fold the bracket. X squared times x squared, we're gonna get x to the power of 4. X squared times negative square root of x, we're gonna get negative x squared times square root of x. This and this, we're gonna get negative x squared square root of x. Square root of x times square root of x, we're gonna get positive x. So now let us add like terms. it's gonna be x to the power of 4 minus this negative x squared times square root of x, and this negative x squared times square root of x are like terms, so we're gonna get 2x squared square root of x plus x. So we cannot differentiate this expression because we still have a radical. We need to make everything to be in an exponential form so that we can apply the derivative. So to change this one, let me simplify this step on a side. So it's gonna be x squared times x to the power of half. When you multiply same bases, you simply add the exponent. 2 plus half, you're gonna get 5 all over 2. So it's gonna be x to the power of 5 all over 2. So it's going to be x to the power of 4 minus 2x to the power of 5 all over 2 plus x. Let me erase here. So now we can differentiate this function. To differentiate this function, it's simply gonna be dy dx all over it's simply dy dx is equal to 4 times 1, it's gonna be 4x to the power of 3. 4 minus 1 is 3, and then negative 2 times 5 all over 2, we're gonna get negative 5 x to the power of 5 over 2 minus 1, we're gonna get 3 over 2. 3 over 2. Then when you differentiate x, you're simply gonna get 1. So this is our derivative. If you've made this so far in this video, thanks for watching this video, and don't forget to subscribe for this video. I'll be creating a lot of content based on calculus. So thanks again for watching this video. Have a nice day.